Math 117. This is Miss Griffith going over 7.2. We're going to use all the information you learned in 7.1 in order to conduct hypothesis testing for the mean for large samples. So n is going to be greater than or equal to 30 here. You're going to know how to find the p-values and how to use them to test a mean, how to use p-values for a z-test, how to find critical values in rejection regions in a normal distribution, and how to use rejection regions for a z-test. Just as a reminder, you know what type tail test you are conducting by looking at the alternative hypothesis. Okay, if the alternative hypothesis has a greater than sign, it's going to be right-tailed. If the alternative hypothesis has a less than sign, it will be left-tailed. And if it is not equal to, it's going to be a two-tailed test. All right. You actually know how to find the p-value. You've done this before. These are the instructions of how you are going to find your p-value. First, you are going to basically find the z-score. And you know that the z-score is x minus x bar divided by the standard deviation, and that standard deviation is divided by the square root n, because now we're always working with a simple random sample or a sampling distribution. Okay, once you find your z-score, you know how to convert it to a probability. All right, you can use your z-score chart. All right, just remember that gives you the area to the left. So essentially, if you needed the area to the right, you would have to subtract the area you found from 1. Or you can simply use normal CDF on your TI Nspire. All right, this will make more sense when we go through an example. Okay, so all of these hypothesis testing that we'll be doing will be using a test statistic. In this case, we are using a z-score. Why are we using the z-score today? Because the size is at least 30. Okay, so n is greater than or equal to 30. We will use the z statistic. All right, well, this is your formula for your z statistic. X minus x bar divided by the standard deviation divided by the square root n. Once you get your z statistic, you will be able to convert that to a p-value. Okay, here's our first example. The CEO of a large corporation recently stated that the average distance his employers commute to work is at most 20 miles. That's going to help us write our hypothesis, our null and our alternative. To test his claim, you construct an SRS. All right, that's important because that's why we are dividing by the square root n here, of 50 employees, and found the mean commute distance to be 21.3 miles. Is there sufficient evidence at the 0.01 level of significance? This is alpha, okay? This will always be given to you in these problems. To show the mean commute distance is in fact greater than 20 miles. Assume the distribution of all such distances is normal with a standard deviation of 4.9. Okay, well, the first step you'll want to do is write your null and your alternative hypothesis. All right, remember here that it says, okay, they're claiming that this is at most 20 miles. Well, how do we write at most? We're going to write that mu, all right, because we're testing the mean, mu is less than or equal to 20. Well, to write your alternative, it's going to be this opposite sign, right? Anytime you have a less than or equal sign in the null, it will be a greater than for the alternative. Well, this, remember, the alternative sign tells you what type tail test it is. because we have greater than, we know this is going to be a right-tailed test. So I'm just going to kind of draw my standard normal curve. 0 is the mean, and I'm going to put z question mark. We don't know what the z-score is yet. All right, so that's the first step, is we are going to calculate the z statistic. All right, we want to take the mean, 20, minus 21.3, okay, divided by 4.9 divided by the square root of n. Well, what is n here? N is 50, okay? So once you plug all of that in, you will see that the z-score is 1.876. So now we know our z-score is 1.876, okay? Well, how do we go from a z-score to a probability? You can either look at your chart, find 1.876 on your chart, find what score matches up, but remember that gives you the area to the left, so you'll have to subtract that from 1. Or the way I prefer to do it, instead of looking at your chart, is you going to menu, probability, distributions, normal CDF. Because it's right-tailed, our lower bound is going to be the z-score we just found, 1.876. The upper bound is just a very big number. I like to write in 6 nines. Mu is 0, sigma is 1. Once you type in all of this in your calculator, you will get that the probability is 0.0303. That's this area right here. So this is 0.0303. Well, you're almost done now. So after you find your p-value, the way you're going to draw a conclusion is compare p-value to alpha. Well, your p-value we just found is 0.0303. Alpha, they gave it to you in the problem, okay? That's the level of significance. That was 0.01. Well, it looks like your p-value is greater than alpha. Anytime your p-value is greater than alpha, we fail to reject the null, okay? Well, what does that mean in the context of our problem? It means that we are not rejecting the null. So we're not rejecting that mu is less than or equal to 20. So that means that we do not have convincing evidence that the commute time is greater than 20. Okay, we don't have evidence for the alternative hypothesis because we are failing to reject the null. Okay, there is a way that you can actually do all of this on your calculator. So your z-score will pop out, and your probability or your p-value will pop out, okay? The way you would do that on a calculator, if you don't want to go through all of this, is, let me get to it, is this, okay? You would go to menu, statistics, stat tests, and then we're doing a z-test today. Why? Because in 7.2, n is going to be greater than or equal to 30. It's going to ask you, do you want to use data or do you want to use stats? Well, we didn't have a list of data here, so you're going to want to switch the input from data to stats, and this is what it asks you. It asks you mu of the null, okay? Well, that, of course, is going to be whatever you put in your hypothesis, okay? So you'll type in 20. It asks for the standard deviation, that's 4.9. It asks you for the mean of the sample, that's 21.3. N is 50. And then the last thing it asks you for is what is the sign of the alternative? Okay, so that had to be correct, so that is going to be greater than. So you're going to need to switch the sign to greater than. And very nice, what pops out is your z statistic Okay, so, and that's exactly what we got when we used the z-statistic formula. And it also gives you your p-value. Okay, so now that you have both of these, you are able to compare your p-value to alpha to make a conclusion. Again, remember when the p-value is greater than alpha, you fail to reject the null. Okay, so that is what we were doing here. If your p-value happened to be smaller than alpha, you reject the null. Those are your only two options. And then from there, you can make a conclusion about the context of the problem.